Hello everyone. Today let's discuss about the Spring Core or the core technologies. The agenda for today is learning about Bean lifecycle, dependencies and configuration. Let's learn that in detail, like the straight values, primitives, strings, etc., and the IDRef element and ref element. Setter injection with primitives, inner beans, dependency check and depends on attributes. Along with that, let's also learn about customizing the nature of a bean, that is initialization and disposable bean, and default initialization and destroy method. Let's recall the concepts of the core container before starting this video. The core container is the heart of the Spring framework, and all other modules, say context, expression language, everything are built on top of this core container. This core container or Spring core, it provides the dependency injection feature. It is also known as inversion of control. Dependency injection or inversion of control is most important concept of a Spring. This dependency injection, it helps to make our code loosely coupled, or in other words, it means lightweight. So, which helps us to manage the dependency between the objects using the configurations. So now let's also recall the Bean factory. Bean factory is nothing but it's an implementation of the factory pattern which creates and manages the life cycle of beans. Beans are also known as application objects. These are defined in the Spring Bean configuration file. So now let's get into understanding of the further concepts of the core container. First comes the Bean life cycle. In a Spring-based application, our application objects, all the application objects will live within the Spring container. So what happens is the creation of objects, wiring all the objects together, configuring the objects and managing their entire life cycle, that is starting from spawning or the new object up till the finalize. So everything the container will manage. So it's very important to understand the container in order to understand the application objects. So let's imagine that in this diagram form. See, let's imagine this is a container within which we are having these objects. The blue colored squares are the objects. These objects are created, wired together and live within the Spring container. The container is the core of the Spring framework. As we already discussed, the container is the core of the Spring framework or heart of the Spring framework, where this container uses the dependency injection to manage the components that make up an application. It also, the functionality is, it includes creating associations and the collaborations between these components. So container is one of the most important part of the core of the Spring framework. So we can imagine this entire video with the help of this diagram. These are the objects which are wired together, connect together, collaborate together within the Spring container. Then let's see this flow. Here the creation and destruction of the beans happen. First is instantiation, next comes populating all the properties needed, set bean name, setting the bean factory, set application context. Then comes the bean post processor pre-initialization. After property set, calling the custom init method and bean post processors post initialization. lastly the ready to use bean, which will later be destroyed by using the destroy method. So this is the entire life cycle of a bean. Hope this diagram helps you for the easier understanding of the bean life cycle. Next comes the topic is the dependencies and configuration in detail. See, first thing what we need to understand, if we recall once again the dependency injection or the inversion of control, it makes our code loosely coupled, that is lightweight. What exactly is loosely coupled? What exactly is lightweight means? The dependency between the objects will not be more. So, how that dependency and configuration happens? Let's get into it. We can define the bean properties and constructor arguments as references to the other managed beans or the collaborators. We already saw there is a connection between each and every application object within the core container. So, mainly the bean properties and the constructor arguments can be passed as references with other bean from one bean to another, which makes the collaboration to happen. So the Spring, which has the XML based configuration data or the configuration metadata, it supports sub-element types within its property and the constructor arg elements for this particular purpose, that is for collaboration. So mainly under dependency and configuration, we will have mostly all the things done with the property and the constructor arg elements mostly. So the ways in which these dependencies and configurations are handled is the straight values or the primitive strings and so on kind of dependencies. Second is the ID ref element is used for a kind of dependency between the objects, and the ref element, which is also known as the collaborator, and how the setter injection is done using the primitives and what exactly is the setter injection. These are the four important topics that come under the dependencies and configuration. So let's first begin with the straight values or the primitives. The value attribute, as we all know, within the property element there is a value attribute. So how can we write that in this topic? Let's see that. See, we are having the value within the property, which within the bean config file we are having the value and the property. So the property name is driver class name, value is com.mysql.jdbc.driver, and the property name is URL, and the value is this JDBC path and the username and the password. So here both the property and the constructor argument is a human readable string representation here. So how can we write that here? We can write that here as property name. We can call the class org.springframework.beanfactory.config.property placeholder configurer, within which we are having property name is equal to properties and the values that we shown here. So it's clearly a human readable representation. So there is an API called Conversion Service API within the Spring, which defines an API for executing type conversion logic at runtime. It helps in type conversion logic execution at runtime. So this is the way how we can represent using the primitives. So what exactly the core container does? It converts the text inside this particular value into the properties instance by using the JavaBeans property editor mechanism. So it's a nice shortcut, and it also helps us in clear usage, and the Spring team gets help with this with the use of the nested value over the value attribute style. Next comes the IDRef element. What exactly is IDRef element? This element, it's an error-proof way to pass the string value or the ID value from one bean in the container to a constructor argument or property element. See, for example, we are having here bean ID is equal to target bean and a class name. Bean ID is equal to the client bean and the class name, and property name is target name. IDRef bean is the target bean. So how can we write this particular bean definition exactly with the same equivalent work it does at the runtime? How we can write that is bean ID is equal to the target bean class name. Bean ID is equal to client, the class name. Property name is target name. Value is the target bean. The same thing is done here with the IDRef element. What it does is directly it gives the name of the target bean. It will give it here, the target bean. So both are exactly equivalent, and it will not give rise to any error as well. So directly we can use IDRef bean is equal to the target bean here. Next is the ref element. It helps us in referencing one bean to other bean, or the collaboration effort is done here with the help of ref element. It's the final element inside the, again it comes under the constructor argument or the property element. What we do is the value of specific property of that particular specific bean will be a reference to another bean or a collaborator. It is managed by the core container. So the referenced bean is the dependency of the bean whose property will be set, and it is initialized on demand as needed by the property. So for example, if we can see here the ref element, the ref bean is equal to some bean, and the bean ID is the account service. This is the ID, and the class name, simple account class. Here what is happening is, here bean ID is the account service. It's the bean name is same as that of the parent bean. So all references are ultimately a reference to another object. So the scoping and validation depend on whether we specify that particular ID or name of the other object through the bean, local or parent attributes. This is the example here. The value of the bean attribute may be the same as that of the ID attribute of the target bean, or as one of the values in the name attribute of the target bean. So ref parent is equal to account service here. See, this is just an example. Ref bean is equal to some bean. This is the bean name or the bean ID. It can take the bean ID. For example, see here, if the bean ID is equal to account service, class is equal to com.foo.simple account service. Here the ref parent is equal to account service, means it is referring to the parent bean here. This name and this name both are same, account service. This is just an example. Some bean is just an example. This is the actual real world example where the account service is the bean name and the parent name just follows this. This ref parent is just the name of the parent bean. Next comes the sector injection with primitives. For this again we need to recall the dependency injection or the inversion of control concept. As we all know, it's the most important concept of a Spring, and the dependency injection, it makes our code loosely coupled or the lightweight, means it helps to manage the dependency between the objects using the configuration. And the Spring dependency injection is configured in two different ways. As we all know, it's XML based as well as annotation based. XML based means we know it's the Spring config.xml. Second is the annotation based. So for all these, the Spring dependency injection, there are three ways in which the Spring dependency injection happens. One kind of a dependency is the setter dependency injection using primitives. So what we need to have in this is, first we need to have, let's neatly understand this setter injection using primitives, setter dependency injection using primitives with a neat example. So for that we need to have a setter bean info.java. It's just a POJO. This setter bean info.java is a POJO. Client controller logic.java is the main function, and the Spring config.xml file is the XML configuration file. So let's have these three codes now and understand this setter injection using primitives. Only thing we need to know first is the setter injection with primitives. It's one of the types of the Spring dependency injection, which is very popular as well, and we need a POJO for this. There is no other, it's a simple POJO, getter and a setter, that's it. POJO means getter and a setter. There is no other dependency like interface. We don't need any base class annotations, we don't need any of those things. Just we need a simple POJO for this, a main method and a Spring XML configuration file. If we have these three things, we will easily understand what exactly is a setter dependency injection using primitives. So let's begin with, first we are having, let's create a Java project here. It's already created, Spring first project demo. Here I am having a setter bean info.java. This setter bean info.java will have a get text and a set text. So getting text in the sense, as we know, it can be some message or some name or something like that. So a getter and a setter within this com.visualpath.spring programs, and we are displaying that particular text as well. System.out.println, printing that particular text. This is what we are doing in setter bean info.java. Next is the client controller logic.java. This logic is nothing but it's a main method first thing, where we are having the resource. That resource object is used to read the config file. This particular config file, it's used to read that particular config file. Next is the Spring config file. Here we are having the bean ID, which is very, very important. Also the POJO class has been defined here. The class where we need to, which is connected and collaborated with the POJO. We need that one as well. That is one thing. Second is, first let's go into the setter bean info.java. Here this text is a property. So what will the Spring do? It will inject the value to this text at the runtime. It will inject the value to this text at the runtime. How it does it? It will do that using this particular line, that is dot get bean. What we do, we get the object of the setter bean here, bean factory dot get bean of this bean 1. It gets the property of this particular setter bean. We get the object of this setter bean object, which accesses, this in turn accesses the display info method here. Display info method here. So there is a neat collaboration between the POJO setter bean info, the main program where we have the logic of getting the bean ID, which in turn calls this display info. Third is the definition collaboration for each and everything. That is, POJO also has the definition here in the form of this class, and the bean as well has the ID name here and the property text here. So everything is neatly binded here. So Spring Config acts as a collaborator here. So what is happening here is, if we run this particular client controller logic.java, we get understanding Spring Setter injection for primitives. So that is what is written here. The value is understanding Spring Setter injection for primitives. The same has got printed here. It is displaying that particular info here. Next comes the inner beans. Inner bean, like how we have the inner classes, a class within the class, within the scope of another class, similar way we are having the inner beans concept. These inner beans are the beans that are defined within the scope of another bean. Whenever a bean is used for only one particular property, it is declared as an inner bean. Inner bean is supported both with the setter injection property and constructor injection, constructor arg property as well. So just like how we use the inner classes which are defined inside the scope of another class, inner beans are the beans which are defined within the scope of another bean. Inner bean is, the example for that inner bean is the bean ID is equal to outer bean, class is equal to outer bean, property name is equal to inner bean, within which we are having the inner bean, bean class is equal to inner bean, which is again bounded within the property later within that particular bean. Beans are defined with inside property tag. In this case, an instance of the inner bean class will be created and wired into inner bean property of the outer bean class. This is the outer bean, this is the inner bean, which is bounded within the property of this outer bean class. So in this example, it's passed as a constructor argument. Here within the bean class is equal to inner bean within the constructor argument of this outer bean. This is an example for that. Here it's within the property. So here all the dependencies or directly or indirectly have everything to deal with and to understand with the property element and the constructor arg element. So if we focus on these two elements, most of the dependencies and configurations are easily understandable. So let's see an example for this. Bean ID is equal to outer bean, the class name. So here within the property element we are defining this inner bean. This is the visual path employee this is an inner bean which is which is present nested inside an outer bean. This is the outer bean, outer, as the name itself suggests, outer. If name is not suggested, we need to understand that the outer bean, within the property of the outer bean, the inner bean will be defined. That is one thing we need to understand. In this inner bean also can have separate properties for itself, like the name, age, or whatever it is. Employee, name and age. This is a simple POJO getting and setting the name of this particular employee. So this is the department name, where department domain, where the employee, that particular employee class, this is an employee class, POJO, get name and set name. So here getting the department number, setting the department number, and allocated to, get allocated and set allocated to, overriding that particular department number and the name. So that is what is being done here. So instead of using a reference to the target bean, simply define the target bean in line here. Next comes how we define all these within the beans.xml. In beans.xml, as usual, we are having this XSD is defined. Within that, we are having bean ID is equal to this particular department number and department domain. This is the department domain. Property name is department number, and allocate this is again an inner bean which has the employee value and the employee name, and the department number is whatever is defined. So how we can understand this is, it does not require a defined ID or a name. If specified, the container does not use such a value as an identifier. It just ignores the scope flag on creation. These inner beans are always anonymous and they are always created within the outer bean. It is not possible to inject inner beans into the collaborating beans other than into the enclosing bean or to access them independently. So, here we are not providing any name here. It is not possible to inject the inner beans into the collaborating beans other than into the enclosing bean to access them independently. Next is the dependency check and the depends on attribute. What exactly is dependency check? It is to check for unresolved dependencies of a bean that is deployed into the Spring IOC container. There are different modes of this dependency check. Let's see it one by one. So first understand the checking of unresolved dependencies of a bean that is deployed. There could be some chances like some dependencies may not be defined properly. So, and which are deployed, such things, for such beans, we need to perform a kind of dependency check and also understand how to use the depends on attributes. So, the dependency check attribute is set in the particular bean element. How can we do this is dependency check is equal to true. Where we are doing that is at configurable annotation, auto_var is equal to auto_var.byName, dependency check is equal to true. So, if this particular dependency check attribute is set to true, then Spring will validate that configuration for all the properties that are not primitives or collections, and it sets those properties. There are 4 modes of dependency check. It's none, simple, object or all. What exactly is none? None means it is default. It means that there is no dependency checking done. The properties of the bean that have no value specified will not be set. There is no value specified means those properties will not be set. Simple means only simple types, primitive types and collections. For those only dependency check will be done. Object means for only collaborators. Next, all means for all kinds of properties, that for all kinds of types like the primitive types, simple types, collections and collaborators. For each and everything, for all the data types, dependency checking will be done. How to use the depends on attribute? Let's see how to use the depends on attribute. If a bean is dependent on another, it means that one bean is set as a property of another. So, usually what we do, we use the ref element in the XML configuration metadata. Sometimes the dependency between the beans are less, that it may not be straightforward. So in such scenarios, we need to use this depends on attribute. Where there is no straightforward way of dependency definition, we need to use the depends on attribute, which can explicitly force one or more beans to be initialized before the bean using this element is initialized. For example, here bean id is equal to bean1, class is equal to example bean, depends on is equal to manager, bean id is equal to manager, class is equal to manager bean. So how we are expressing this kinds of dependencies on multiple beans. So we can, if it depends on multiple beans, then we provide a list of bean names as a value of the depends on attribute. We use commas, white spaces and semicolons as well. So how we do that? Let's see this example. Bean ID is equal to bean1, class is equal to example bean, depends on manager as well as account DAO. So it's separated using a comma. So property name is equal to manager, reference is manager. Bean ID is equal to manager, class is equal to manager bean. So bean ID is equal to account DAO. It means this is a bean which is having the property. So these two beans, this manager, the class is the manager bean, account DAO, it is referring to this class x.y.jdbc.jdbc account DAO. So in the bean definition, we can specify both an initialization time dependency and in the case of singleton beans only, a corresponding destroy time dependency. Dependent beans that define a depends on relationship with a given bean are destroyed first before the given bean itself being destroyed. So depends on, it also means that it will also provide a kind of destroying of that particular object bean. Next, customizing the nature of a bean. As we already saw in the bean life cycle, it starts with the init method and it will end with a destroy method. So the bean life cycle understanding is very important, which is completely managed by the container. So the container, what it does, it calls the after property set and the destroy, as we already saw here. This understanding of this flow is very much important. This one, instantiate, populate properties, set bean name, set bean factory, set application context, and here this is the after property set. So what is happening here is, when we talk about the nature of a bean customization, there are two interfaces which we talk about, initializing bean and the disposable bean interface. When the container calls that particular after property set and the destroy respectively, what it does is, it allows that particular bean to perform certain actions upon initialization and destruction of our beans. Internally, the Spring framework, what it does is, the bean post processor which we saw, that implementation it will use to process any callback interface. It can find also, it calls the appropriate methods. Sorry. So we also have the initialization and destruction callbacks, and the Spring managed objects may also implement the life cycle interface so that these objects can participate in the startup and the shutdown process as driven by the container's own life cycle. What exactly is initialization callbacks? org.springframework.beans.factory.initializing bean, this interface allows a bean to perform the initialization work. After all the necessary properties have been set by the container, this particular interface, it specifies a single method, that is void after property set throws exception. But we usually see that initializing bean interface will not be recommended because it is tightly coupled. We already discussed what exactly is tightly coupled. It means there is a more dependency between the beans or the objects. There is a more dependency of the code to the Spring. So this helps, this creates a lot of overheads. So there should be always less dependency of the code to the Spring. So this usage of this initializing bean interface creates it makes unnecessary tightly coupled situations. So we can alternatively use this at post construct annotation, which is used to specify a POJO initialization method. For the XML config metadata, we need to use the init method attribute to specify the name of the method that has no argument signature. How we do this? Let's see here. We are having the bean ID name example init bean and the class examples.example bean. Init method is equal to init. Public class example bean, public void. This is some do initialization work. Some code will be there here. This init method attribute is used. It is exactly same as using this, that is bean id is equal to example init bean, class is this class name, public class another example bean implements initializing bean, that is public void active property set. So here some initialization code is there. Doing this is same as this functionality, that is using active property set and doing the initializing code, but it does not couple the code to the Spring. That is what is expected. If we use this initializing bean, it will definitely couple the code, means it will make the code tightly coupled to the Spring framework. Tightly coupled means there will be more dependency of each and every object. So which is not at all desired. So we always do this. We use the init method is equal to init. This example is very important and doing the initializing work here. Next is in the similar way how we understood the initializing callback, the same way we need to understand this destruction callback. Implementing the org.springframework.beans.factory.disposable bean interface allows a bean to get a callback when the container containing it is destroyed. The disposable bean interface specifies a single method, void destroy throws exception. It is recommended not to use, though we understand this for the sake of purpose of it, we must not usually use this because again it unnecessarily couples the code to the Spring. Alternatively, we can use the pre-destroy annotation or specify a generic method that is supported by the bean definitions. That is, in the XML based configuration metadata, that is string, within the bean XML, we can neatly use the destroy method attribute on the bean. How we use that? We can see here. See, this is what is not recommended because it will tightly couple to the code, couple the code to the Spring framework, making it more dependable between the objects, which is not desired. So what we do is we have to go ahead with this. That is bean id is equal to example init bean class name, destroy method is equal to cleanup, here public void cleanup. So here it will release all the pooled connection and everything will be cleaned up. So this is what is expected. Though this is rather present, but usually the usage is not recommended for specific purposes as it tightly couples the code to the Spring. Next is default initialization and destroy method. As we saw in the bean life cycle, the life cycle of a bean starts with the initialization till the destroy. So these initialization and destroy method callbacks that do not use the Spring specific initializing bean and disposable bean callback interfaces, how we write it is as init, initialize, dispose, such methods we usually use. The name of such lifecycle callback methods are standardized across the project so that all the developers use the same method name and ensure the consistency. The same method names if we are using on every bean, there will be a kind of consistency because some people using this disposable bean and the initializing bean, some other developers using this init, initialize, dispose and destroy. So it doesn't make any uniformity. So everyone usually use these as a default. We can configure the particular Spring container to look for named initialization and destroy callback method names on every bean. Means as an application developer, we can write the application classes and use the initialization callback called init. So without having to configure an init method is equal to init attribute with each bean definition. So usually the better thing is to use init method and the destroy method. Init for the initialization callback and destroy as the destroy callback method. The Spring IOC tells that method when the bean is created. It also, this particular usage of uniform feature enforces a consistent naming convention for the initialization and destroy method callbacks. So with this, we are ending the agenda for the day of learning some of the most important concepts related to the core container or the core technologies of the Spring. If you are having any doubts, get back to me. Thank you very much.